Yes, disconnects are required for storage-type water heaters. To elaborate further, let's explore the relevant electrical codes and best practices concerning the installation and maintenance of storage-type water heaters, specifically focusing on a 50-gallon unit with a 4,500-watt heating element. The National Electrical Code, or NEC, provides guidelines designed to ensure electrical safety, and these guidelines often mandate the presence of a disconnect switch for appliances like water heaters. The primary reason for requiring a disconnect is to provide a readily accessible means of cutting off power to the appliance during maintenance, repair, or in emergency situations. This ensures the safety of personnel working on the equipment and prevents accidental energization while work is in progress. Firstly, let's consider the specific NEC requirements. While the exact wording may vary depending on the specific edition of the NEC enforced in a particular jurisdiction, the general principle remains consistent. The NEC typically requires a disconnecting means to be located within sight from the equipment, or be capable of being locked in the open position. This means that the disconnect switch must be either visible from the water heater's location, or if not visible, it must have a mechanism that allows it to be locked in the off position to prevent unauthorized re-energization. Secondly, the purpose of the disconnect means is multifaceted. It allows electricians and maintenance personnel to safely de-energize the water heater before performing any work on it. This is crucial for preventing electrical shock hazards. Also, it provides a convenient way to shut off power in the event of a malfunction or emergency, such as a leak or overheating. Furthermore, the disconnect switch simplifies the process of replacing the heating element or performing other routine maintenance tasks. Thirdly, let's discuss the types of disconnects that are commonly used for water heaters. A standard single-pole or double-pole switch, enclosed in a metal or plastic box, is a common option. The switch must be rated for the voltage and amperage of the water heater. For a 4,500-watt water heater operating at 240 volts, the current draw can be calculated using the formula power equals voltage x current. In this case, 4,500 watts divided by 240 volts equals 18.75 amps. Therefore, the disconnect switch should have a rating of at least 20 amps to provide a safety margin. Another option is a circuit breaker located in the electrical panel. If the circuit breaker is within sight of the water heater and readily accessible, it can serve as the disconnecting means. However, if the circuit breaker is not within sight, a separate disconnect switch must be installed near the water heater. Fourthly, consider the installation requirements for the disconnect switch. The switch must be installed in accordance with the NEC and local electrical codes. It should be mounted in a readily accessible location, typically near the water heater but not directly above it, to prevent water damage in case of leaks. The wiring connections must be properly made and tightened to ensure secure and reliable connection. The switch should be clearly labeled to indicate its purpose, such as water heater disconnect. Fifthly, it's important to address the grounding requirements. The water heater and the disconnect switch must be properly grounded to provide a path for fault current to flow back to the electrical panel, tripping the circuit breaker and preventing electrical shock hazards. The grounding conductor should be connected to the grounding terminal and the disconnect switch and to the water heater's grounding lug. Sixthly, consider the specific requirements for a 50-gallon water heater. The size of the water heater does not directly affect the need for a disconnect switch. The requirement is based on the fact that it is a permanently connected appliance. However, the size of the water heater may influence the size of the branch circuit conductors and the overcurrent protection device, such as a circuit breaker or fuse. Seventhly, maintenance and inspection are also essential. The disconnect switch should be periodically inspected to ensure that it is in good working condition. The switch should operate smoothly and make solid contact when closed. The wiring connection should be checked for tightness and corrosion. If any problems are found, the switch should be repaired or replaced by a qualified electrician. Eighthly, regarding local codes and regulations, it is imperative to consult the local electrical codes and regulations in North Carolina, as these may have specific requirements that go beyond the NEC. Local codes may specify the type of disconnect switch that is required, the location of the switch, or other installation requirements. The local electrical inspector can provide guidance on these requirements. Ninthly, when selecting a disconnect switch, consider the following factors. Firstly, choose a switch that is rated for the voltage and amperage of the water heater. Secondly, select a switch that is suitable for the environment in which it will be installed. If the switch will be exposed to moisture or dust, choose a switch that is NEMA rated for those conditions. Thirdly, consider the ease of installation and maintenance. Choose a switch that is easy to install and that has readily accessible terminals for wiring connections. Tenthly, it's also important to consider energy efficiency. While the disconnect switch itself does not directly affect energy efficiency, it can help to reduce energy consumption by allowing you to easily turn off the water heater when it is not needed, such as when you are away on vacation. 11thly, let's address common mistakes to avoid. A common mistake is failing to install a disconnect switch at all. This can create a safety hazard and may violate electrical codes. Another common mistake is installing a switch that is not rated for the voltage and amperage of the water heater. This can cause the switch to overheat and fail, potentially leading to a fire. Additionally, improper wiring connections can also lead to problems such as loose connections or short circuits. 12thly, the NEC also addresses specific wiring methods for water heaters. Commonly, flexible metal conduit, or FMC, or liquid-type flexible metal conduit, or LFMC, is used to connect the water heater to the disconnect switch. These wiring methods provide mechanical protection for the conductors and allow for some flexibility in the installation. The conductors must be sized according to the ampacity requirements of the water heater and the NEC tables. 13thly, the NEC also provides guidelines on the overcurrent protection for water heaters. The overcurrent protection device, such as a circuit breaker or fuse, must be sized to protect the branch circuit conductors and the water heater from overloads and short circuits. The overcurrent protection device should not exceed the ampacity of the conductors or the maximum overcurrent protection rating of the water heater. 14thly, it's essential to understand the difference between a circuit breaker and a disconnect switch. A circuit breaker is an overcurrent protection device that automatically trips and interrupts the flow of electricity in the event of an overload or short circuit. A disconnect switch is a manually operated switch that is used to turn off power to an appliance or piece of equipment. While a circuit breaker can serve as a disconnecting means if it is within sight and readily accessible, a disconnect switch is not an overcurrent protection device. 15thly, consider the impact of the disconnect switch on the overall electrical system. The installation of a disconnect switch may require modifications to the existing electrical system, such as running new wiring or installing a new circuit breaker in the electrical panel. It's important to ensure that the electrical system is adequate to handle the additional load of the water heater and the disconnect switch. 16thly, the NEC also addresses the issue of accessibility. The disconnect switch must be readily accessible, meaning that it must be located in a place that is easy to reach and operate. The switch should not be obstructed by obstacles or located in a hazardous location. 17th, let's consider the perspective of the electrical inspector. The electrical inspector will inspect the installation of the disconnect switch to ensure that it complies with the NEC and local electrical codes. The inspector will check the wiring connections, the grounding, the rating of the switch, and the location of the switch. If the installation does not meet the code requirements, the inspector will require corrections to be made. 18th, when troubleshooting electrical problems with a water heater, the disconnect switch is an essential tool. By turning off the disconnect switch, you can safely de-energize the water heater and perform tests to diagnose the problem. For example, you can use a multimeter to check the voltage and continuity of the heating element and the wiring connections. 19th, it's also important to consider the environmental impact of water heaters and electrical systems. Energy-efficient water heaters can help to reduce energy consumption and lower utility bills. Properly installed and maintained electrical systems can help to prevent electrical fires and other hazards. 20th, remember to always prioritize safety when working with electricity. If you are not comfortable working with electricity, it's best to hire a qualified electrician to install the disconnect switch and perform any other electrical work. Electricity can be dangerous, and it's important to take precautions to protect yourself and others. It is of utmost importance to energize the circuit and verify that the power is off using a reliable voltage tester before commencing any work. Always follow safe work practices, wear appropriate personal protective equipment, and adhere to all applicable safety regulations. If you are unsure about any aspect of the installation, consult with a qualified electrician. 21st, there are different types of water heaters that exist, including tankless and heat pump. Each has their own set of characteristics. Tankless water heaters heat water on demand, eliminating the need for a storage tank. Heat pump water heaters use electricity to move heat from one place to another, rather than generating heat directly. This makes them more energy efficient than traditional electric water heaters. 22nd, the voltage of the water heater is important. Standard voltages include 120 volts, 208 volts, 240 volts, 277 volts, and 480 volts. Make sure that the voltage of the water heater matches the voltage of the electrical system. 23rd, proper labeling is important. Any electrical panel and disconnect should be labeled clearly, indicating what it is for and what it powers. This helps with safety when working on electrical equipment. 24th, regarding wire size, make sure to use the proper wire size as calculated by the ampacity and distance according to the NEC for water heaters. Undersized wires could overheat and cause a fire hazard. 25th, when in doubt, it is best to consult a qualified electrician. The electrical work can be dangerous, and it is best to leave it to the professionals. They have the knowledge and experience to safely and correctly install and maintain electrical systems. 26th, electrical codes are in place to protect people and property from electrical hazards. They are constantly evolving to reflect new technologies and best practices. Staying up to date on the latest electrical codes is essential for ensuring electrical safety. 27th, proper grounding is essential for electrical safety. Grounding provides a path for fault current to flow back to the electrical panel, tripping the circuit breaker and preventing electrical shock hazards. Make sure that all electrical equipment is properly grounded. 28th, be mindful that permits may be required for electrical work. Check with the local permitting office to see if a permit is required for the installation of a disconnect switch or other electrical work. 29th, electrical safety is everyone's responsibility. By following electrical codes and best practices, we can help to prevent electrical accidents and ensure a safe environment for ourselves and others. 30th, the 4500 watt water heater is a common size of electrical water heater. This is something to be mindful of when selecting a new water heater for a home.